Welcome back. We'll go over problems from Stat7 1. There are only 3 problems. Problem 1. Suppose the scores of students on an exam are normally distributed with a mean of 556 and a standard deviation of 31. According to the empirical rule, what percentage of students scored between 525 and 587? Let's look at the empirical rule. This is the empirical rule. Okay, for a normal distribution, there you go. This is the picture for empirical rule. Mean, 1 standard deviation away, you have 68 percentage. 2 standard deviation away, you have 95 percentage from here to here. And 3 standard deviation away, you have 99.7 percentage of the population under the curve. So you want to figure out what these numbers represent in comparison to 556. So let's get our workspace ready and calculator ready. All right. So first of all, you are looking at mean of 556. And then we are told the standard deviation is 31. And then the question is 525 minus 2587. So let's state the question. What percentage of students scored between 525 and 587? All right, I hope I got the numbers correct, 525 and 587. Okay, so that is your mean. So let's see how far, if you want, you might want to draw a picture. So you have mean to be 556. Yeah, so somewhere here is 556. Okay, standard deviation is 31. So 1 standard deviation is over here, 1 standard deviation less, 1 standard deviation more. 2 standard deviations less, 2 standard deviations more. So you need to know these numbers, whether these numbers fit any one of these. So notice, if I look at mean minus standard deviation, I get 525. So 1 standard deviation away is 525. Okay, this is 1 standard deviation to the left. Let's take mean plus 31. So that would be on this side. So 556 plus 31. That's 587. So this one is 587. So you see, this is your mean. You subtract 1 standard deviation, you go here. You add 1 standard deviation, you go here. So you are looking at 1 standard deviation away. What does the empirical rule state? It states that within 1 standard deviation, so that's mu, and 1 standard deviation to the left, 1 standard deviation to the right, 68 percentage live. So that's your percentage, 68. All right, next. The heights of American men are normally distributed with a mean of 65.9 inches, standard deviation of 5.7. So under these areas over this and so on and so forth. So it's the same kind of problem. We are using the empirical rule. Let's quickly go over this here. What is the mean? Mean is 65.9. And what is the standard deviation? 5.7. All right. So you want 60.2 to 71.6. So let's figure out how many standard deviation that is. Right? So mean is somewhere precisely in the middle. Right? That's 65.9. And you have a certain standard deviation which you are going to subtract and bring it here. One standard deviation over, if you add, you bring it there. If you subtract two standard deviations, you have some number there. From the mean, you add two standard deviations, you have some number there. If you subtract three standard deviations, you get a certain number there. If you add three standard deviations, you get a certain number there, and so on and so forth. So let's figure out the calculators, right? There you go. Okay. So mean minus one standard deviation. 65.9 minus 5.7 is 60.2. So one standard deviation, this one is 60.2. That is one standard deviation less than the mean. If I add, I get 71.6. So that's 71.6. Okay. Now, so one of the questions is, here, 60.2 and 71.6. So that's just one standard deviations away. And we have seen one standard deviation away from the left to the right gets me 68%. So this is 68%. Now, under 48.8, where is 48.8? So let's look for 48.8. That has to be subtracted from here. So I'm going to subtract one standard deviation that got me here. I subtract another standard deviation that gets me 54.5. So let me write it down. And if I subtract one more standard deviation, I get 48.8. All right. So the question wants you to be under 48.8. That is, you want to be in this region. So let's look at our empirical. So that's three standard deviations. Notice we had to subtract from here 3 times, right? So that's three standard deviations to the left. So between three standard deviations, you have 99.7%, which tells me 0.3% is split between this area and this area. So you see, 0.3 has to be split between these two areas, okay, over here. So 0.3 split equally will be, I have to divide by 2, so that gets me 0.15 over here and 0.15 over here, percentage, mind you. So that's how much is under 48.8. So 0.15. Next question, over 54.5. So 54.5 is here. You want to be above 54.5. So let's figure out. So 54.5 is what? 2 standard deviations to the left. So I'm looking here. So everything above. All right. So what's going to happen? 13.5 plus 34 plus 34 plus 13.5 plus whatever this was, right? This is 2.35 and above. That above, the last above is this 0.15. So I want to add all of this. Okay, there is an easy way to add everything starting from here, and that easy way is, look at that, mu minus 2 sigma. So 2 standard deviations to here is 95 already. So let me start with 95, and then I'm going to, so starting from here until here is 95, that's given to me. Now I'm going to add 2.35, and I'm going to add that last teeny bit. That last teeny bit, if you recall, was half of the 0.3, so 0.15, 0.15. Okay, now submit all of these and you're done. Next problem I'll start on a next video. Until then, bye.